Hi, everybody. Thank you for joining me for the homework tonight. So we talked about like parts of expression and how to simplify today, which is also known as combining like terms. But this is just kind of solidify your knowledge and make sure that you know everything you absolutely need to know before moving on to practicing and application and all that harder stuff. So this would be a nice little check-in. Do you know what you need to know? Did you pick up what you were supposed to pick up from today's lesson? All right, first and foremost, let's talk about parts of an expression. Open up the top flap. Now here you will see we have an expression and we have an expression. Now when we talk about these pieces, we'll be basing it off of this one, but this is just for us to talk about the different parts. First and foremost, this is not just an expression, it's a special expression. It's an algebraic expression. Algebraic expression. What makes it algebraic is that it contains a variable. Speaking of, what is the variable here? Well, here, this is a variable, which is a letter that we use to represent things we don't know yet. And this is also a variable up there. But this one is different from this one because this is x to the second power, and this is just x. So that's the difference there. Now, in class, we talked about something special, which was the one piece of an algebraic expression that does not have a variable. And that would be this guy right here, which is -7, because remember, it takes the sign in front. This is called a constant. You might remember from last year them singing a song like "The Constant Stands Alone." Constant stands alone. Well, that's what it is. The constant stands alone. Now these guys that are in front of or connected to our variables using multiplication are called coefficients. Coefficients tell us how many of these we have. So here we would say we have 5 x squareds and we have 9 x's if you think about our algebra tiles. They are just the numbers that are attached to our variables. So if we were to list our coefficients, it would just be 5 and 9. Notice we don't write our variables with it. For our variable terms here, we would have x and x squared. And for our constants, we simply have -7. Okay, let's look down below. We're going to use this expression to list all of the following. So first and foremost, let's list our coefficients. Remember, our coefficients are the numbers that are attached to our variables using multiplication. So here's one right here. We have 9, comma, a +7, comma, oh, that's a constant. There isn't a coefficient then. Here, there's a very special coefficient that's invisible of 1, because that would be like 1x algebra tile, so there's one of them. Constant, oops, no coefficient. And then finally we have -4, because remember it takes the sign in front. As for constants, let's look at everything that does not have a variable. Here we go. There's a constant right there of -2 and a constant right here of +5. Notice when I'm boxing it, I'm taking the sign with it so I know whether it's positive or negative. Now here we're going to list all of our different terms that we have right now. We have our first term, which is 9x squared. We have our second term, which is 7x. Then our third term, which is -2. Our fourth term, which is a 1x. Our fifth term, which is 5. And our sixth term, which is -4x squared. Now, if we wanted to talk about the number of terms, we would have to combine our like terms. Like terms are terms that look alike. They have the same variable and the same exponent on that variable. Same variable, same exponent. So here, an example of like terms would be 9x squared and -4x squared. Another example of like terms would be 7x and 1x. Another example of like terms here would be -2 and 5. All right, now that we've kind of talked about the parts of an expression, let's open up this bottom flap, and we're going to do just 3 of them together because this is an old skill, and then you guys will be responsible for the other ones, meaning like you'll give them a shot, we'll see how you do, and we'll go from there. This will be a good indication if you need to be an extra help tomorrow morning or not. First and foremost, let's talk about this one that deals with fractions. So remember, we need to identify our like terms. You guys in the past have put this into a T-chart. So let's go ahead and make ourselves a little T-chart. We can see right away we have a variable of k and constants. So we have k and a number. Now, to identify our like terms, I like to use shapes and colors. So I've got 1/2 k. And what's a like term with 1/2 k? Notice I'm writing it in the column. This one's a tricky one. You have to take both signs. Be careful when you're boxing so you don't cover up one of the additions, subtractions, or anything like that. What happens here is that it becomes a plus. So this would become a 2/5 k. And that's all we have for k's. Now let's talk about our numbers or our constants. We have -8. Notice how I'm very careful to not cross out that negative or make it look like a plus sign by putting my circle through it. I list it in my column. Then we have a +2. Now that I have my like terms separated into our T-chart, we can now add down. 1/2 k plus 2/5 k gives us 9/10 k. -8 plus 2 gives us -6. Now that I've combined my like terms, I need to write this as a single expression. So we're going to take 9/10 k out. We have 9/10 k. And then because this is a -6, we will say this is -6. You could also write 9/10 k plus a -6, but this is the better, more math mature way. All right, so combining like terms, we need to make our T-chart, put our like terms into columns. Here we had k and we had constants. Then we add down, get our answer, and then our final step is to write it as a separate expression. All right, next let's slide on down and take a look at this one. Again, we're going to make our T-chart. How many columns should we have? Hopefully you said 2. We need an X column and a Z column. I make my Z's like that because my Z's kind of look like 2's, so that's a Z. Now let's identify our like terms. I always start with the first one and I put a box and I use colors and I say, okay, my first term is 2.5x. What is another like term? Hopefully you thought to yourself, this one. Notice again, I'm boxing the sign in front, so I know it's a +1.6x. Are there any other x's? Nope. Cool. Let's do the next one. We've got a +1.8z. Notice I'm very careful to not cross over the sign, and I take it with it. I use a different shape and a different color. 1.8z. This has a like term of negative. Notice I'm very careful not to cross over that sign so I can clearly see that this is a -0.9z. Now I need to add down, and I've got 2.5 plus 1.6 is 4.1x, and then I've got 1.8z plus a -0.9z is 0.9z. Therefore, our final answer will be 4.1x, and then because this is a positive number, it will then be plus 0.9z. Finished. Now, finally, we're going to do this one together. All right. I like to look first and I like to say, okay, how many like terms am I going to need? Or how many columns, not how many like terms, how many like terms do I have and how many columns do I need? So I've got -10k squareds. Remember, they have to have the same variable, the same exponent. So these two are not like terms because this is k squared and this is just k. A like term here would be negative 3k squared. Is there another k squared? There sure is. Negative k squared. So far that's one column. Let's take a look and see. Okay, next we have a positive 7k. Does that have any like terms? It does. Positive 5k. Now we've got one term that has nothing under it, and that's a plus 4. That means that I need 1, 2, 3 columns because I've got 3 colors. So I've got k squared column, k column, numbers column. In our k squared column, we will have negative 10k squared, negative 3k squared, and negative k squared. What's invisible in front of that k squared? A 1. I highly suggest writing that in so you don't forget it exists. Next we have our k's, which is positive 7k and positive 5k. And last but not least, we have our numbers, which is just a positive 4. When we add down, we have negative 10 plus negative 3 is negative 13. Negative 13 plus a negative 1 is negative 14. Negative 14k squared. The variable and the exponent just come along for the ride. Then I have 7k plus 5k gives us 12k. And then 4 plus nothing is just 4. Now let's write our answer outside of our t-chart. We have negative 14k squared. Positive 12k makes it a plus 12k. Positive 4 makes it a plus 4. And that is your simplified expression.